Here's a problem about area. We're inside the square from -4 to 4 in both x and y. 4 regions live in there. Above the curve, y equals x squared over 4. Below its mirror image, and the same 2 curves again, but sideways, in x instead of y. The problem asks for the area of top and right, top and left, bottom and left, bottom and right, all put together. That's the shape we're after. Before computing anything, it's worth noticing what those 4 curves actually are. They're the same curve rotated a quarter turn 3 times over. So it makes sense that the shape repeats itself 4 times around the center. By rotational symmetry, all 4 pieces have the same area. So let's forget 3 of them and focus on the top right petal. Whatever its area is, the total is 4 times that. Here's the useful part. The boundary of the top piece is y equals x squared over 4. The boundary of the right piece is x equals y squared over 4. The same equation with x and y swapped. Swapping x and y in an equation is exactly what reflecting a curve across the line y equals x does. So the second curve isn't a new shape to work out. It's the first one reflected. The piece I want is the sliver caught between a curve and its own mirror image. A curve and its reflection cross each other exactly where the curve meets the mirror line itself. So, where does y equals x squared over 4 cross y equals x? Set them equal. X squared over 4 equals x. That gives x equals 0, or 4. Those are the 2 corners of the sliver. It opens at the origin and closes back up at the point 4, 4. Between those 2 points, the mirrored curve sits above the original one. Solved for y, it's 2 root x, and that stays above x squared over 4 the whole way across. So the piece is just the area between 2 root x and x squared over 4 from 0 to 4. 16/3. That's 1 petal. 4 of those, since the whole picture repeats, 64/3. The square itself is 8 by 8, 64. A third of that is also 64/3. So these 4 petals take up exactly a third of the square they live in. The strange thing is that the coefficient, the 1/4, never actually mattered. Repeat this with y equals cx squared for any c, and match the square to where the curve meets the diagonal. The 4 petals still occupy exactly a third of it. This picture isn't a coincidence. It's a family. See you in the next problem.